What is an event? Well, this is the commonly used English word, but we're not going to use the Google definition of this because this is a math video. We're going to understand this word in the context of the chapter probability. Let's get started. To understand this, let's toss two coins. What do you get when you toss two coins? Well, let's list down all possible outcomes that can occur. And by the way, we know that this is also called sample space. So the sample space will have these possible outcomes. Either we can have both of them as heads, or we can have the first one as heads and the second one as tails, or the first one as tails and the second one as heads, and finally, both of them as tails. There's nothing else that can happen. These are the four possible outcomes. Now let's get creative. Suppose we want to understand how do we get these scenarios. How do we get exactly one head? How do we get exactly two heads? At most one head, or at least two tails. We can get exactly one head by either having the first coin as heads or the second coin as heads. That's it. Now how do we get exactly two heads? Well, there's only one way. Both of them have to be heads. And how do we get at most one head? Well, at most one head means maximum number of heads is 1. So either we can have 0 heads, which means both of them as tails, or either one of them as heads and the other one as tails. Now how do we get exactly two tails? Again, there's only one scenario when both of them are tails. Now think about it. What did we do here? We made smaller groups of the outcomes from the sample space. In math world, we call them subsets. So to define what an event is, we can say that any subset E of a sample space S is called an event. All four of these are called events, and we can have many more of them. And this is how you'll see them in your textbooks. You'll see them written in the set notation. So we have the set S, which is the sample space, which has these four outcomes. And then you have these four events, which are subsets, and that's the keyword, which are subsets of the sample space. So that's it. Events are subsets of sample space. Now, how do we know that an event has occurred? Let's again toss two coins. This is our sample space. Now let's assume that this is what we get. We toss two coins and we get the first one as heads and the second one as tails. The question for us is, this event E, which is exactly one head, has this event occurred? Think about it. Well, there's nothing much to think about. We can actually see that there's exactly one head on the screen. We have the first one as heads and the second one as tails. So yes, the event has occurred. In this case, the first coin was heads, but we could have also got the second coin as heads. For this other outcome as well, we can say that the event has occurred. If we had gotten anything else, then we would have said that the event has not occurred. Alright, let's move on. Let's talk about types of events. We can have our sample space back, and let's look at a few examples. Let's suppose we have this event which says we need 14 heads. Another one, 9 tails. Okay, one more, 0 heads and 0 tails. What can you say about these three events? Can you have these events? Are these events possible? Well, no. If you toss two coins, these events are not possible. And hence, they're called, surprise, impossible events. Let's look at a few more examples. Another event E which says 0 or more heads. Another one, less than 10 heads. One more, at most 2 tails. Think about it. Are these events possible? Well, yes, of course they're possible. In fact, they're always going to happen. We're always going to have 0 or more heads. We're always going to have less than 10 heads. And we're always going to have at most 2 tails. So these events are called sure events. There are many more examples, but I picked a few interesting ones here. So this is one way to look at different types of events. Let's look at one more. Again, my sample space and these 4 outcomes. Look at these events. One event is we get 2 heads. Another one, a head and a tail. One more, a tail and a head. And a fourth one, 2 tails. What can you say about these 4 events? Well, the technical term here is these are simple events. Why simple? Because they only need one outcome or one sample point from the sample space. Let's look at a few more. We have an event which says at least one head. Now to get at least one head, we need either both heads, the first one head or the second one head. Another example, at most one head. Now for at most one head, we need either 2 tails or the first one tail and the second one head or the first one head and the second one tail. That's how you get at most one head. Now these examples have more than one sample points. They have, in this case, 3 sample points each. When you have more than one sample points, you're no longer looking at simple events, you're looking at compound events. And this is your second way to classify different types of events. Let's move on and now look at the algebra of events. Things are looking interesting. So this time, let's roll a die. Now when you roll a die, this is your sample space. You get 6 possible outcomes, 1, 2, 3, 4, 5 and 6. Let's look at these 2 events. The first event is A, which is 1 or 6, and the second event is B, which is 3, 5 or 6. This means that if you get 1, you can say that your event A has occurred. For example, if you get 5, you can say that your event B has occurred. Now when will A not occur? This is called the complement of A or event A dash. This will happen when you'll get 2, 3, 4 or 5. Alright, so what will be the complement of B? That's the event B dash, and that will occur when you'll get 1, 2 or 4. Basically, you get rid of all the elements that you have in B and you'll pick whatever's left from the sample space. That's when B will not occur. Let's look at a few other cases. What about event A or B? What about event A and B? And what about event A but not B? Now, or, and, but not, these are again English words, and I encourage you to pause the video and think about these events. Now, A or B means either A or B or both have happened. Again, A and B means both A and B have to happen together. And A but not B, that means event A has happened but B does not happen. Now, if we apply this logic, this is what we get. For A or B, we get 1, 3, 5 and 6. What we have done is, we've picked elements from A and B both and put them together in this set. Because either one of them can happen for us to get event A or B. For A and B, we only have this element 6 because that's the only element that is common in both A and B. What this means is, both A and B can together happen only when we get a 6. If we get a 1, we'll have event A happening but not B. If we get a 5, we'll have event B happening but not A. The only way we can get both A and B to happen together is when we get a 6. Now the last one says A but not B, which means A has happened but B does not happen. So for A to happen, we need 1 or 6. But if 6 happens, event B has happened. So what we can do is we can remove the 6 and only put 1 here. The way to do this is, you start with elements of A and you remove the elements that are common in both A and B. That's how you'll get A but not B. Now let's look at the last important thing about events. And in my opinion, one of the most confusing things about this particular topic. Let's roll a die one more time. And the sample space here is 1, 2, 3, 4, 5, 6. Let's look at these events. Event A is the set of odd numbers. Event B is the set of even numbers. What this means is, event A has occurred when we get an odd number and event B has occurred when we get an even number. We can say that there's nothing in common between A and B. Either the number is odd or the number is even. For this case, we can say that event A and B are mutually exclusive events. When there's nothing in common, we call the events as mutually exclusive. Alright, let's move on. Let's look at another example. Event A is just 1. Event B has all the prime numbers 2, 3 and 5. And event C has the composite numbers 4 and 6. What can we say about event A, B and C? Well, if you add all of them up, you get the entire sample space. Together, they cover up all things possible. When this happens, we call these events as exhaustive events. They've exhausted all possible outcomes. Together they've exhausted all possible outcomes. So there you have it. On the left, you have mutually exclusive events, and on the right, you have exhaustive events. One interesting thing that you can note here is the events on the left are not just mutually exclusive, they're also exhaustive. Think about it. Together, the odd numbers and even numbers also cover up the entire sample space. Events could be both mutually exclusive and exhaustive. We'll cover more examples in our problem solving videos. Now let's summarize. This is what we learned in this video. We talked about what an event is, how do we know whether an event has occurred or not, different types of events, impossible and sure, simple and compound, and we also looked at the algebra of events. We talked about the complement of an event A or B, A and B, A but not B, etc. And finally, we looked at what mutually exclusive events and exhaustive events mean. Alright.